So we're going to review how to solve absolute value equations. This was days 8 and 9 in your unit 1. So you can go back and look up the same notes that I did. You have access, but I'm going to just kind of re-go over the basics of solving an absolute value equation. Before we do that, let's just kind of remember what absolute value does. So if you remember, absolute value always spits out the positive version of the number. So the positive number. So say I need to solve this equation for x. I want to know what can I put inside here that's going to give me 6. Well, hopefully you're thinking, okay, x equals 6. Exactly, right? Absolute value of 6 is still 6. But if the absolute value also spits out a positive number, I could technically plug in x equals -6. And that's also going to give me a positive 6 because once I take the absolute value of -6 just spits out the positive version of that number. So I actually have two solutions here. X equals 6 and x equals -6. Let's look at this one. Here it says the absolute value of x is 0. Well, clearly you're probably thinking, okay, x is 0, but that's it. We can't have a negative version of 0 because 0 is neither positive nor negative. So I just have one solution this time because when we equal 0, that's really all we can do. Then I look at this last one, and you're probably thinking, okay, so it's x equals -9. Wrong. It is not, because look at back what I just said. We remember that the absolute value is always a positive number. So this is saying that the absolute value equals a negative. This is impossible. It can't be negative. It just never works out that way. So this is actually no solution. So you're going to have multiple types of options. You might have two solutions, you might have one solution, or you might have no solutions. So keep that in mind as we are working through these problems. Remember that absolute value is always positive. So absolute value is that distance from 0, and it's always positive. So I want you to think about if you're driving from your house to McDonald's, say you're going south, right? Which is the downside. You don't say you're -5 miles away from McDonald's, you just say you're 5 miles away. So think about absolute value as just a distance. We all only care about this distance from 0 or some other point. So we don't care if it's positive or negative, we just want to know how far away is it. So feel free to pause this at some point. I'm just kind of going through your own notes, but let's just go ahead and start figuring out how to actually solve these equations. So in summary, we have those three options. If my absolute value of x is greater than 0, meaning it's equal to 6, then I'm going to have two solutions, the positive and the negative version. Because again, on the inside, it doesn't matter what we have on the inside, but the outside will always be positive. So for this example, like we just did in the do first, x could be 6 and x could be -6, because once we plug it in and put on those absolute value lines, it's going to turn into a positive. Option 2 is if it's equal to 0, then we're just going to have one solution because there's no negative, right? So we only get one answer. X would equal 0 in this case. And option 3, if our absolute value is less than 0, then that means there's no solution because absolute value can't be negative. We're not saying that x can't be negative, but we're saying whatever the absolute value is equal to, that can never be negative. So let's see how we would solve absolute value equations. Step 1 is we basically look at what c is, and I call c just that number that the absolute value is equal to. And we have to ask ourselves, is c a negative? Then if it's yes, that means there's no solution because absolute value can't be negative. If c is 0, then that means we're just going to set the inside equal to 0 and find one solution. If c is greater than 0, meaning c is just a positive number, that means we're going to have two solutions, which means we're going to write two equations. So let's actually look and see what we got for this first example. Here it says the absolute value of x minus 4 equals 6. So what this is saying is that this inside could either be 6 or -6. Because that inside, once it's 6 or -6, once we put those absolute value lines on, it's going to spin it into a positive. So what I'm going to do is figure out, okay, when can x minus 4 equal 6? Or I know that the inside, x minus 4, can equal -6. I have two equations. So I'm going to solve both of these for x. Let's just figure out what x could be. Well, if I add 4 to both sides, then I get that x could equal 10. Same thing here, if I add 4 to both sides, x could also be negative 2. And you might be saying, but Miss, I thought it can't be negative. I'm not saying that the x can't be negative. I'm saying that what the absolute value is equal to has to be positive. So with that, x can either be 10 or negative 2, because when we plug it back in, we're going to get a positive answer. So if you want, let's just check and see why this works. So when I check, I just use my original equation. So when I'm checking x equals 10, I'm going to plug in x equals 10. So I have absolute value of 10 minus 4 equals 6. Well, 10 minus 4 is 6, so is the absolute value equal to 6? Yes, it is. Let's check the x equals negative 2. So I take the absolute value of negative 2 minus 4, and I want to see if that's equal to 6. Well, negative 2 minus 4, that's negative 6. But when we take the absolute value of that, we still get 6. So this is still a true statement. Let's do another example. Here I have the absolute value of 3x plus 1 equals negative 5. So again, my first step is just to check C, and I notice, well, that's negative. No matter what I plug in here, this absolute value wants me to equal some positive number. So this is no solution. No solution, because absolute value cannot be negative. So if you would like to pause and look over these examples that we've already worked in class, go ahead and pause and just make sure you understand. Okay, so now let's look and kick it up a notch. Sometimes we need to maybe isolate, or meaning get by itself, the absolute value before solving the equation. So when I'm looking at this, I see, oh, it's equal to a negative. That might be no solution. No, that's not wrong. Or sorry, that is wrong, because we first need to isolate. Meaning I want to get this little section all by itself on this side of the equal sign. So what's in the way is I have this minus 10. So I'm just going to move that to the other side. Think about basic algebra. If I have a minus 10, this is subtracting. I'm going to add 10 to both sides. So now I have the absolute value of 3x plus 9 equals 6. And look, now it's positive. So it's still saying that my absolute value is equal to a positive. I just had to do a little bit of work to make sure I saw that. So this is going to mean I have two solutions, meaning you have to write two equations. Okay, let's look at this one. Here, we would maybe need to eliminate. We see that we have this 2 out front and this plus 1. Well, this plus 1, that's adding, so I subtract 1 from both sides. So I still have the 2 times the absolute value of x minus 3 equals 10. Now, you might think with this 2 that you can distribute. No, sir. Do not distribute, because those absolute value lines are like a jail cell. Don't go inside them if you don't want to. So to undo multiplication, we're going to divide by 2. So we're going to divide both sides by 2. So this becomes the absolute value of x minus 3 equals 5. Because this is positive, we would solve our two equations and get two solutions. So let's look at these examples real quick. Notice on this one, my first step was I had to move this plus 5. So I subtracted 5 from both sides and got 4. So because it's positive, I'm going to write two equations. One equation can be that inside x minus 2 can equal 4, or that x minus 2, this inside, can be equal to negative 4. So we solve both of those, so x can be either 6 or negative 2, because once we plug it in, it's okay, we're going to still get a positive number. Same thing here, we had to isolate first before we could write our two equations. So we had this plus 1 and the 4. We got rid of it and got down to this point. So then we set up two equations. So guys, on your exit ticket, you will have to have two answers. Two answers. Notice here I have x equals negative 3 and x equals negative 11. So double check. I don't want to just see one answer. A lot of y'all missed that. You need to have two. Okay, so I'm going to pause this, and now we're going to look at some inequalities. Okay, now we're going to look at a little bit different of a problem where now we have this like x on the other side, and it's just a number. So whenever you see an x, you can go ahead and write your two equations. So all of my absolute value, it's isolated, it's by itself. Because that's not really positive or negative right now with the x, we're going to still write two equations. So one's going to be x plus 9 equals 2x, or the other one is x plus 9 equals negative 2x. Now we're going to solve these for x. So I want to get all of the x's together and all of the constants together. So I see that I have an x and 2x on this side. I'm going to subtract 1x. So think about this is 1x and this is 2x's. Let's get them together. I move it from here. This goes away, so I get 9 is equal to x. Because 2x's minus an x is 1x. So there's one solution. Over here, I'm still going to do the same thing. I'm going to subtract x. Here I get 9 equals negative 3x. Now, I still need to divide to get x by itself. This is saying negative 3 times x. So I divide both sides by negative 3, so I get negative 3 equals x. Now, because this x can change, right? That x can be positive or negative or whatever it wants. We need to check for something called an extraneous solution. So extraneous solutions, we want to double check and make sure that our absolute value equals a positive. So with extraneous, here's the trick. You just check. So I'm going to plug in x equals 9 and check. So I have 9 plus 9, I'm just plugging in x for 9. And it's equal to 2x, so I'm still plugging in 9. So I get the absolute value of 18 equals 18. Okay, that makes sense. X equals 9 is good to go. Now let's check when x is equal to negative 3. So every time I see an x, I'm going to plug in negative 3. So I get negative 3 plus 9 equals 2 times negative 3. And I notice here that the right side, this is going to equal negative 6. So regardless of what I have in here, which is still just 6, I can't have an absolute value equal to a negative, right? We said absolute value is always equal to a positive. So what this means is even though I did all the work right, this is extraneous because when I plugged it back in to check, I got it equal to a negative. So whenever you have an x on both sides, be extra careful and just double check your answers to make sure that they still make that right side or that equal to a positive. Okay, now we're going to do some inequalities. Really, these are very similar. The steps are all the same. The first step is we isolate. Then the second step is we still write two equations if it's positive. If positive. If we have a negative, then this time you're going to need to think. Because now we're thinking about inequalities, meaning we're not equal to something. When this says it's less than 2, we can be anything less than 2. 1, 0, negative 1, right? It's saying this can be equal to anything that's like equal to 2 or smaller than 2. So my first thing is I have my absolute value by itself. Then I see that I have a positive number. That's positive. So we're going to write two inequalities. 2, 2, 2. So I know that the x plus 7, that can be smaller than 2. Or I can write that x plus 7 is, I'm going to flip the sign greater than or equal to, and I'm going to make it negative. Negative 2. So I solve both of these for x. I get x can be less than negative 5, or x can be greater than negative 9. So basically x can be in a lot of different places. So when we do these, we usually have to graph and kind of explain where. So here's negative 9, here's negative 5. X can be smaller than negative 5, so I'm going to draw it this way, or x can be greater than negative 9. So what we're saying is everything for x can be anything between negative 9 and negative 5. Okay, notice on this one. Here I have that the absolute value of 8x minus 11 is less than 0. So think, can my absolute value, right, this is equal to a positive number, can that be smaller than 0? No, that's impossible because it's always positive. So this is actually no solution. Now, so remember, if it's smaller than a negative, that's no solution because it can't be less than 0. If it's greater than a negative, then that can be anything at once because it's always greater than 0.